Okay, so this is one of the key concepts of physics, is scalars and vectors. Hopefully this is something that you have covered before slightly in math, so it might be a review, but let's talk about them. Alright, so in physics you always have to distinguish between two types of quantities. Scalars, which in my opinion would be the simpler kind of thing, and it's just something that has a size. Alright, so something to keep in mind, a scalar quantity is only going to have a number and then some sort of unit to identify what that number represents. So like 5 meters or 20 meters per second, all right, or 50 newtons. Those would all be scalars. Whereas vectors have a number, a unit, and a direction that these things are occurring in. Okay? So another way to think about it is vectors are something where you can have it going forward or backwards. In which case, in order to give the right instructions to the person who's trying to interpret your quantity, you have to include the direction. Alright, so these could be, 5 meters west or positive 50 newtons. Okay? Things like that. So, let's take an opportunity and see if you can come up with any more examples. Try to focus on things that don't have a direction. So see if you can come up with other types of units. Okay? So if you need to, pause this, write down what you can, and just to help you zone in on some ones you might not think of. Hopefully in your list you might have come up with something, say, any times. Alright, so time is a scalar quantity because we haven't figured out how to go backwards in time yet. You can also think temperature. Alright, so, and I know our units, when we think about like Fahrenheit or Celsius, there are negative temperatures, but we'll get into this eventually. Your SI unit for temperature is actually a Kelvin. Alright, and 0 Kelvin means the complete absence of temperature. There are no negative kelvins. Alright, so temperature is another scalar quantity. Alright, and we'll work with this more throughout the course. But just to keep in mind, it's a magnitude only, no direction. So, same idea, do some practice with vectors, come up with some things. Alright, just a few things to keep in mind, or some quantities that maybe you're not quite thinking of yet, but like velocity is a vector. Alright, you can have positive and negative velocities. Acceleration. Alright, you can increase speed, decrease speed. Also force. Alright, a push or a pull has to go in a certain direction. Like you push a box to the right, or you push a box to the left. Okay? Stuff like that. So, the vectors are, because you have to have that direction. When you draw a vector, you have to do it in a very specific way. Alright, so we use arrows in order to draw vectors. And the point of the arrow is what indicates your direction. Alright, so east or left or right. Alright, the arrowhead will point in the direction that you are implying. So let's talk about direction a little bit more. There's two major ways to discuss direction on a vector. There are the cardinal coordinates, north, south, east, west, or, there's also northeast. And eventually we're going to get into some great detail with this, with angles and, to what degree things are northeast or southeast and vector components. But for right now, we're actually going to focus a little bit more on the Cartesian coordinate. Alright, so something that goes to the left, alright, is considered a negative direction. And if you think about, like on a number line, as numbers increase, that's going to be positive. As they decrease, you have to subtract, so that's negative. Alright. Another thing, anything that is going down is also considered negative. Alright. Whereas the opposite of that is where you get the positives. So anything going up is positive, and then anything going to the right, or like kind of increasing on a number scale, would be considered positive. All right, so we're going to focus on this for chapter 2 when we think about things in one dimension. So it can either go backwards or forwards, or can only go up or down. All right, we'll get into this stuff more into chapter 3. So let's do a little bit of practice with this. Pause the video, try answering these questions, and then turn the video back on and I'll go over the answers with you. So if you pause this, give an example of a scalar quantity. So all I needed was some sort of number with a unit. All right, and hopefully you challenge yourself to go with units that can only be scalar, like time, like temperature. All right, vector quantities are things where you're going to have directions. All right, so this would be an example, would be a velocity, 16 meters per second south. Could have done -5 meters. Could have done, positive 70 newtons, something like that. All right, then drawing a vector that shows a magnitude with a negative direction. You didn't have to draw a specific, size vector or anything like that. Big thing is I wanted to make sure you can draw something with a negative direction. So you either should have drawn a vector to the left or a vector that went down. Okay, either one of these would work. So that's the end of this video, but there is a little bit more. I'm just breaking the video up into chunks for you. So move on to the next one.